Okay, so today we're going to be talking about organizing our data, and then also we're going to be evaluating some observational drawings. So first we're going to start with organizing our data. When you're testing your experiment, we know that you have to do how many trials? Show me with your hands. How many trials do we have to do when we are experimenting? Seeing some different answers here. I know for STEM fair, every single time you do a STEM fair, you need to have at least 5 trials. As you're doing those 5 trials, you're collecting your data. It might be a measurement, it might be some time that you took with a timer. Whatever it is, you usually have to put it into a chart and then make a graph out of it, right? Okay. So we have 2 different types of data here. So go ahead and you can grab a highlighter so we can highlight these definition words. We have 2 different types of data. The first type we have is a categorical data. Somebody read me the definition for categorical data. Somebody read me the definition for categorical data. Ashton.
Data that can be assigned qualities or categories. They are non-numerical data.
Non-numerical data. When we say non-numerical data, that means that these are not things that have numbers. If I'm writing, that means you're writing. These are things that do not have numbers. So for example, let's say I took a survey and I asked everybody in class what your favorite kind of fruit is. Okay? And I had a chart and I wrote down all the different kinds of fruit. Would that be a hard measurement? Like I could do something with a ruler, or I could use a timer and time how many seconds.
Yes. No. No. Wait, no.
Gavin, can you explain why you said no?
I said no because you can't use a ruler or a timer. You have to write everyone's name down in certain places.
Right. It's not something I'm measuring. I'm just writing down what their preference is. So this would be an example of a categorical data. It's something that doesn't have a number. On the opposite end, we have measurement data. And that sounds exactly what it is. It's a data that you can count or measure. So let's say that I was dropping a ball from off the roof, and I was counting how many seconds it took to get to the ground. That would be measurement data because I would have a number afterwards. 10 seconds maybe. So this is something that has a number. All right, so now what we're gonna do is we have this little T-chart right underneath and all of these different experiments that we have up here, and we're gonna sort them into either categorical or measurement. Remember, measurement is what we can measure. Categorical, we cannot measure with numbers. All right? So let's first take this one, football teams. If we walked around the classroom and I took a poll on what everybody's football team was, do you think that's something we could measure with numbers, or do you think that's something that we would just have to write in categories?
Categories.
Andrew, thank you for raising your hand.
Categories.
Why do you think that?
Because you can't just measure how much people like the team.
Right.
You have to write their names.
Exactly. You can't measure that with a ruler or a timer. So football teams would go on the categorical side. What about if we talked about how many boys versus girls there were in class. Would that be categorical data or would that be a measurement data? Levi?
That would be measurement data because there would be the numbers saying how much boys and how much girls.
Yeah, there would be a hard number that we could use. There are 17 boys and there are 5 girls. That's what, it would just be a number afterwards. Ben? Okay. All right, now we're gonna do this one right at the top here. Favorite kinds of food. I want you to figure out, does that go in categorical or does that go in measurement? Do it on your own. Favorite types of food. All right, Darnell, what do you think? Categorical? Okay, why do you think that?
No, you don't put numbers. You gotta put the names
Mhm.
of the people's favorite foods.
Good, very good. All right, what about the cost of a ticket? Be careful, Ben. The cost of a ticket, go ahead and figure that one out on your own. Is it categorical data or is it measurement data? The cost of a ticket. Heather, what do you think?
I think it's measurement data
Okay, why do you think it's measurement?
because it's like putting the numbers. It's like about numbers.
Yeah, it's about numbers, it's about money. So all the different money that we would have for the cost of a ticket would go in here. All right, I'd like you to do this column right here on your own. If you don't know what grade point average is, it's like, they kind of do it in middle school and high school. It's they take all of your grades and they assign it a number. So like an A would be 4 points, a B would be 3 points, a C would be 2 points, and so on. And then they average them all together to get like your number of your grade point average. So you're doing this column on your own. Give me a thumbs up when you have those 3 things sorted into this T-chart. It's like they take your grades and they assign it a number and they average them together to get like a score. Okay, Andres, where do you think grade point average should go? Measurement data, do we agree?
Yes.
Okay. What about age? Sienna? Measurement? Do we agree?
Yes.
Darasimi, why don't you agree?
I think it's categorical.
Okay, why?
It's not measuring how old someone is.
So you're not measuring how old someone is, you're kind of just figuring out what their age is and then maybe like putting tally marks?
Yeah.
I'd say maybe it could go in categorical data as well. Okay, distance. If you're measuring distance. Layla?
Measurement data.
Measurement data, very good. Okay, We're going to move on to the next one. Okay, now that we have our data, it's time to organize the data. And the way that we organize data is by using graphs. So we have 5 different types of graphs here. The first type of graph is a bar graph. Somebody read me what a bar graph is used for. Levi.
For comparing data
And 2 or more categories.
Okay, comparing data in 2 or more categories. Raise your hand if you've ever seen a bar graph before. Okay, a bar graph kind of looks like this. You have your numbers along the side here, and then you usually have your categories down here, and then you shade the bar like this. Think about in your data notebooks, we have bar graphs where we're tracking where our sprints are and where we are tracking our test scores and our AR goals. Those are all bar graphs. All right, the next one, a line graph. Somebody read me what a line graph is used for. Jaden.
a tool for comparing data that changes over time.
Okay, so a line graph is used for something over time. So again, similar to a bar graph, it would have the numbers up the side here, and it would have the categories down here. Maybe you're testing your height every year for 5 years. So maybe one year you are 3 feet, maybe the next year you're 4 feet, and the third year you're 5 feet, and then maybe the year after that you're only like 5'2". We would connect the dots, and it would show your growth over time. Okay. Yep. Growth over a period of time. Okay, what about a pie graph? What is a pie graph used for? Haley.
A tool for comparing portions of a whole that fall into different categories. Pie graphs should not be used unless the percents add up to 100 or the parts that add up into one whole.
Very good. So a pie graph looks like a circle, and then we have parts of the pie graph sliced into pieces, and then a pie graph is used for percents. So the whole thing equals 100%. So this part might be 75%, this part might be 20%, and this part might be, well, it would have to equal 5%. Obviously it's not to scale because the 5% would be much smaller. But this is what we would use if we were having percentages. Okay? Like let's say that we took a poll and we figured out what everybody's favorite color was in the class. And we figured out the percentage. So 75% of you,